This is the review for the radiology final exam, and you have access to the paper copies of both of these pages of final exam review notes. And my suggestion would be to go through your notes, go through the PowerPoints, the textbook, especially the diagrams in the textbook, and look through and just make sure that each of these items you can answer and talk about in detail, because that's going to be the biggest thing that will help you for the final. I've broken things down into topics so that they're a little easier to study and organize, so hopefully they make a little more sense. So I'm just going to talk through each of the points. First, we'll start with KVP. And with KVP, just make sure that you know how KVP relates to contrast. And just, you had your little scale, the little gray scales that were at the bottom of some of your PowerPoints that talked about how low KVP equals a short scale of contrast, but that means that there was high contrast between the shades of gray. A higher KVP means that it's a longer scale of contrast, and that means that there's a low contrast between each of the shades of gray. So basically the way to understand that is low KVP means that you've got weaker x-rays, so they either get through or they don't, so you have a shorter scale because there's fewer grays between radiopaque and radiolucent. That means that there's a bigger step between each shade, which is where the high contrast comes in, but because it's fewer shades of gray, you have a short scale. It's the opposite with high KVP. Turning the KVP up means that the x-rays will get through more structures to get to the film or the sensor, so you're going to have more shades of gray. So with the more shades of gray, you have a longer scale, and there's not as much difference between each shade, so you have a low visual contrast, but a longer scale. Look back through your notes, make sure you know aluminum filtration as it relates to KVP. You have a certain amount of filtration for below 70 KVP and a certain amount, and it's in millimeters, so make sure you find it, for 70 KVP and above. We talked about KVP with scale of contrast a couple of items ago. And then what happens when the high voltage circuit is activated? So that's going to be back to that diagram that we drew on the whiteboard. And remember, the high voltage circuit was when your anode and cathode were activated. Your electron cloud is going to come across in the cathode stream. They're going to hit that tungsten target and produce either heat or x-rays. So when I say what happens with high voltage circuit activation, that just means be able to talk your way through that diagram and kind of follow the train of what happens once the cathode and anode are activated. The next item is MA. Make sure you know what MA controls. MA controls the heating of the filament. With heating of the filament, you get the number of electrons in the electron cloud that forms the electron cloud on the cathode end of the tube. So just make sure you know that with your MA, you're controlling how many electrons are available in that electron cloud. The end result of what that means is with higher MA, you'll have more electrons, which means you'll have more x-rays. Not necessarily stronger, but more. If you turn the MA down, then you'll have fewer electrons, which means you have fewer x-rays. Again, they're not weaker or stronger, it's just more or less. So MA controls how many you have, or the quantity. It's KVP that controls how strong they are, or the quality. Make sure you know how MA affects density. And the answer to that is the more x-rays you have hitting the film or the sensor, the darker it's going to be. The fewer you have, the lighter it's going to be. So MA doesn't have anything to do with your contrast. That's strictly a KVP thing. MA does control your density though. Let's see. The next item on this list is processing. So with processing, go back through the handouts that you had provided in the class when we talked about film and processing, because you'll need to know the purpose of the fixer and the developer, what each one of those chemicals do and how they affect the film, and what part of the processing is controlled by either the fixer or the developer. You'll need to know your times and temperatures, how those affect the fixer and the developer. If the processing chemicals are too cold, what happens? If they're too hot, what happens? So make sure you know your time and temperatures. That would also cover if you leave the film in the developer too long and you overdevelop it, or if the film is left in the fixer too long, or if they're not in there long enough. So you either underdeveloped or underfixed. So with times and temperatures and the effects, that's what I'm looking for. The proper processing time and temperatures for both manual and automatic. You had a handout that really spelled out those steps and what the time was for each of those portions of the process. I'm not going to ask you the chemicals specifically, because we didn't talk about the individual chemicals within the fixer or developer, so don't worry about that part. Anatomy, you had a handout for that as well. Your textbook has some diagrams and some actual radiographic images that would help you study for that, but just make sure you know your maxillary and mandibular landmarks. You can have diagrams that you'll have to label, images that you're looking at that you would have to label, or it could just be a question: what is the arrow pointing at? Or it could be a question without an image: which of the following landmarks is maxillary or found on a maxillary, molar, periapical? And you would need to know what anatomy is included in each of those images to be able to answer those questions. Similar to that, make sure you know radiolucent and radiopaque. So if I ask you a question, which of the following landmarks is radiopaque, you would have to know from the multiple choices which ones were radiopaque and which ones were radiolucent to be able to answer it. And then I already covered what is and what is not present in each film. So if you had an image that you're looking at and I had an arrow and I'm asking you what that landmark is, you'll need to know what should be in that image and what shouldn't. Then we get to just some general things. What determines film speed? So we talked about that with the different objectives that you were taking the notes on. And when you're talking about the film speed, that's when you're talking about the size of the crystals and the size of those silver halide crystals. So the larger the crystals, the faster your film is. So that's the question that it's asking for there. And remember that the film speed is A through E, and A is your slowest and E is your fastest. But then it goes, kind of an F and E are the most commonly used ones. We didn't talk specifically about who discovered X-rays, but that was in your assigned reading in the textbook, so you'll be able to find that information, who discovered X-rays and when. Make sure that you know that impulses, which is how we measure X-ray production, that's the time that we measure in, impulses are 60 per second. So you would have 60 impulses per second. Some of your troubleshooting errors, again, there was a handout just on troubleshooting errors. Make sure you know processing errors, what makes black marks, why would the film be brown, your exposure angles. So when we talked about if you had too much vertical angle and not enough vertical angle, or if your horizontal angle was off. So just make sure you know what those errors are and what they look like and how to fix them. Placement errors, that's going to be things like missing the apex, and not having the correct tooth. You could have that as missing the crowns. Those are your placement errors. And then cone cuts, make sure you know that cone cut is not an angle issue most of the time. Angling issues are going to be your overlap and foreshortening elongation. Cone cutting is typically just, the quick definition is that you didn't cover the film or the sensor with the PID. So just make sure you kind of know the difference between those. Now, in reality, if your horizontal angle is off a lot, you can create a cone cut. Even your vertical angle can create a cone cut, but that's not typically what I'm looking for. Typically, what I'm looking for when I ask about cone cut on an exam is going to be incomplete coverage of the film or sensor with the beam or the PID. Things that can cause film fog, that's going to be light leaks, outdated film, things like that. Again, look at that handout that we did for troubleshooting because it's listed on there as well. Intra and extraoral images, the advantages and disadvantages of each. I think I posted a video, that was the horrible video right before we left campus, but there's a video of that as well as a handout that breaks down each of the types of images and the advantages and disadvantages and just a quick why you would take each one. The process of producing x-rays step by step, again, that's that diagram of the x-ray tube. Just make sure that you can look at that diagram either labeled or not. And I had a little exercise for you guys. You may want to practice that again, just so you can label the different parts, and then you can talk your way through what each of those parts does, what is its purpose, and talk your way through, heating of the filament forms the electron cloud, then your anode and cathode kick in, that's your high voltage circuit, and that then the electrons travel through the cathode stream to the anode end, they hit the tungsten target. Remember, the speed of the electrons traveling across is determined by your kVp, and they hit the target, then you have x-rays and heat produced. And even walking your way all the way through the filter and the collimator, just make sure you can go through that diagram and label each part and describe what each part does. The components of the film packet, you've got a diagram in your textbook as well as in a handout that just tells you what each part of the film packet is and what its purpose is. The different types of radiation, what I'm looking for there is your primary beam, the backscatter radiation, those types of radiation. I'm not looking for specific types, just the types that we interact with. Make sure you're familiar with that bisecting the angle technique. We talked about it kind of quickly. There was like one slide, I believe, or maybe two slides that described that technique. Most of what we've done in lab has all been the paralleling technique. So just make sure you're familiar with the bisecting the angle. Quality assurance and quality control. You've already seen all the questions I have on quality assurance and quality control, so don't be surprised if you see those again. Those weren't super tricky questions. Interpretation of films. Go back through that PowerPoint and just make sure that you're familiar enough interpreting the images. Density, contrast, how to look at a radiograph and read it. I know a lot of things came up kind of back and forth this semester. Ms. Coy had talked to you guys about diagnosis, and diagnosis has to be made, the final diagnosis, which is typically, when we say diagnosis, we are talking about the final diagnosis. The dentist tells the patient what they see. But we also have, especially in radiology, we have that preliminary diagnosis, which is where you can look at the radiographs and you can tell the dentist what you see, but you can't tell the patient. So just to kind of clear that up a little so there's no confusion going into the final. Final diagnosis has to be made by the dentist, but you can interpret the radiographs, do a preliminary diagnosis, but the only person that you can give that to is the dentist. Tissue sensitivity, remember you had your list, you had your 3 most sensitive and your 3 least sensitive. And just in case you see some different terminology, radio resistant means that it's resisting the effects, so it's not sensitive. And radiosensitive means that it is very sensitive. So radioresistant would be your lower risk tissues, and the radiosensitive would be your higher risk tissues. So just to kind of clarify some terminology, make sure that you know your safety rules and your safety breakdown. Everyone that's not directly involved has to leave the room. If there's no protective wall, you have to stand 6 feet away at 90 to 135 degrees. So just make sure you're familiar with those safety terms and the rules for radiation if there's no wall. Okay, I am going to try to change pages and not make a big mess. Okay, I talked earlier when I was talking about MA and KVP, I talked about quality versus quantity of x-rays. Make sure that you're familiar with those terms. Quality is going to be determined by the KVP. That determines how strong or weak your x-rays are. Quality is how many. Quantity is how many, and quantity is determined by your MA. How many electrons determines how many x-rays you'll have, and it's just strictly the numbers. Quality is talking about how strong they are, so how fast those electrons travel across the cathode stream and hit the target determines the quality or the strength, which is KVP. Duplicating, we talked about really quickly, but duplicating, just remember that that's done. We have the original radiograph with a copy or a duplicating film on top of it, and you either use infrared or ultraviolet light. They are not duplicated again with x-rays, but then they're processed in the processor just like you normally would. And that would be if you're using film, but you have to do a referral, or for insurance purposes and things like that, you'd have to make copies. So just some definitions that I wanted to put in there to make sure that you were familiar with. And I'll kind of go through these really quickly. But ionization, we talked about with the X-ray protection and the safety terminology. Ionization is when we were talking about the free electrons that are trying to join into other atoms to regain stability. So remember, go back through those notes. Penumbra, I don't specifically remember talking about penumbra in class, but it's in the reading. But penumbra is just talking about the fuzziness around the edges. So look back through and find that, and then there are images with examples of that. Your units of measurement, if you remember that handout, the units of measurement, you had the list of old and new terms. So make sure that you know the terms, the old and the new set of terms, and what they measure. Filtration and collimation is just underneath. So filtration and collimation, make sure that you understand what those two are. Those are both considered safety features, but filtration is it's an aluminum disc that sits in the path of the beam, and it filters out any weaker x-rays. The strong ones pass through, but the weaker ones don't. Collimation, remember, is the one that's shaped like a donut. It's made out of lead, and x-rays don't pass through it at all. Lead blocks, or another word you may see in the exam is attenuate. Attenuate means that it stops or blocks it. So lead is going to stop or block the x-rays. So instead of filtering out weak x-rays like the filtration, collimation actually restricts the size and shape of the beam. So just make sure you're familiar with those two terms and how they're used for safety purposes. The lead apron, and I didn't put on here, but the lead apron is to protect your vital organs. And then you also have the thyroid collar. The thyroid protects the thyroid gland. But remember, if you're taking a panoramic, you would take the thyroid collar off because it will end up in the image if you don't. Some other terms, I've got them kind of listed out just in case you see them on the exam. You've got Alera, which remember is as low as reasonably achievable. MPD is maximum permissible dose. So don't just be familiar with that term. Make sure you know. Remember, those were broken into occupational and non-occupational numbers. And there are some exemptions to the occupational numbers. So just make sure you're familiar with maximum permissible dose. And then target to film distance and object to film distance. That is something that's found in the change problem portion of this course. So assisting students don't have to worry about that. Hygiene students would. You would have those change problems that you'd have to work out. We talked about density a little earlier when we were talking about MA and KVP. Both of those do affect density. And remember, density is the overall blackness of an image. So if something is too dense, it's too dark. If it's not dense enough, it's too light. And so kind of think through the process of if you're adjusting the strength of the beam, so KVP, what would make the image come out too dark and what would make it too light? If you're adjusting the MA, what would make the image too dark or too light? So just kind of think through that process and make sure that it makes sense in your head. We talked about latent image when we talked about film. Remember, that's when your film has been exposed but it hasn't been processed yet. So the image is there, it's just not visually present. You can't see it with the eye. It has to be processed first. And then when we talked about latent period, it was kind of the same concept, but it's with damage. With latent period, that means that the person or the item has been exposed to radiation and the damage is present but not apparent or visible yet. Compton scatter we talked about when we talked about how X-rays lose their energy. So you'll find that, again, it's in that radiation safety PowerPoints. Intensifying screens, make sure you know what those were. We had some trouble on the exams with intensifying screens. Those are going to be found in cassettes for your extraoral images. So in a cassette for an extraoral image, you've got those intensifying screens, and go back through and read and make sure you understand how those work, because the purpose of an intensifying screen is to reduce the dose of radiation that the patient receives to expose the image. With an intensifying screen, the screens are hit with the X-rays, and that causes little phosphor crystals inside the screen to give off light. It's the light that exposes the film, not the X-rays themselves. And the purpose of that is that it takes a lot less radiation to light up those screens than it would to expose the film to radiation. So read back through the part about intensifying screens, because intensifying screens was an area that we kind of struggled earlier in the semester. We talked about foreshortening and elongation. Go back through that interpretation PowerPoint slide and the handout that I gave you for troubleshooting, and that'll give you some good definitions and examples of foreshortening and elongation and what causes those. The primary beam, just make sure you know what the primary beam is. We've already talked about the types of radiation. Density, contrast, scale of contrast. We've kind of covered all of those when we were talking about KVP earlier. And that's not a typo, that is definition. I want to make sure you understand what definition is within an image. That's talking about how crisp and clear the edges are. And when you look at it visually, how clean and focused, for lack of a better word, the image is. And then, of course, make sure you know radiopaque and radiolucent. Find a good way to remember those. When you're taking the final, one of my biggest bits of advice, read the questions really carefully, because if you're reading through a question and it says, which of the following is not an example of a radiopaque landmark? If you're too quick reading it and you see radiopaque, you may look down at your options and the first thing you see is radiopaque, so you click it. So just make sure you're reading the questions really carefully. Look out for the except and all but and those types of exclusion type questions, and make sure you're reading that radiolucent and radiopaque really carefully. Good luck, guys. You're going to do great. If you have any questions, email me, and hopefully I can help clear everything up. But you're going to do great. It's been a joy.